Hi, hello, this is Ahmed from FKP Institute of AI. Welcome to time series forecasting sessions, part 1 and session 4. In the last session, we have learned about what is HP filter, how it works, and what exactly it does. Let's summarize quickly about HP filter. HP filter is a tool to extract trend and cyclic components from a given time series. HP filter algorithm works with a smoothing parameter called lambda. This algorithm minimizes an objective function. In the trial of minimizing it, it comes up with the trend and cyclic component values at each period on the time series. Before going into today's session's major concept, that is seasonal decomposition, I have a humble request. Please subscribe my channel. It encourages me a lot. Okay, I think you understood. Yeah, please. So, all right, let's get into today's topic. So let me open the slideshow. Okay, so seasonal decomposition we are going to see. So first we'll discuss like what is decomposition. So decomposition we did even in the last session, okay, but this algorithm name itself has seasonal decomposition. So on the overall, I mean at the high level, so let's talk something about. We'll spend like 1-2 minutes on decomposition. Decomposition meaning extracting each component of time series and visualizing it separately, so that we will get an opportunity to study each component individually, and we can cross verify with what we have in our mind. Okay, so is that the data what we were thinking to feed to the model to get the predictions, right? So decomposition helps to select the forecasting models. Basically, we select the forecasting models based on the data we have, based on the components we have in our time series. That's why decomposition it really important to forecast the time series values. Okay, so I'm basically like I'm going to introduce you 2 words going forward, like we are frequently using them throughout the coming sessions. Those are models of time series. Okay, so those are additive model and multiplicative model. Additive model, when you say how I can say my time series is additive model. So when you observe seasonal and residual components doesn't vary with your trend component in the time series, then you can say you have a additive time series model, meaning your company's brand value is rising, so that your business is rising, that is called trend is going high. So during the seasons, if your sales is doubling, tripling, the when your brand value was not this much what we have now. Okay, so if it is not changing, even though your company's brand is high and your business is doing a lot more better than previously, and your trend is going high, but your seasonal sales, or you can say seasonal component, is not moving much. It's going normal way. It doesn't show much spike in the seasons. So you can say your time series is additive. Your time series has additive model. Okay, so this you can say this is the graph of our additive additive model. So the black color one is the actual time series, and the red one is the seasonally adjusted series, meaning so from the original time series, what you are doing is like you have did the minus of seasonal component. You have removed the seasonal component. Whatever you are seeing here is the trend plus residual component. So residual components, like in most of the times, like we will be having residual component is it's like a very small component. Okay, so overall what we are seeing here is the trend component, which is seasonally adjusted from the original series. Okay. Now let's go to the multiplicative model. So when I can say the time series, what I have is a multiplicative model. So when I observe the seasonal sales is high when the trend is high. When the trend is high, when trend is going low and seasonal sales also going low, and my seasonal component and the residual components are moving along with the trend, then I can say, you know, the model, the time series I have is multiplicative model. So since it is like a multiplicative model, so we can define it as our series, that is observed series, is equal to trend into seasonal component into residual component. But whereas in case of additive model, we'll use like plus symbol, because it will not go in quadrant way of moving, that is exponential way of moving. The business is not going in case of additive model. But whereas here, so what happens, it's a into, it's exponentially business goes, okay, not in, you know, higher degree, but it is a multiplicative of the components. Okay, so that way, so that way here, so to find out the trend from our time series model, what we are going to do is, from the observed series, we need to divide this time, divide our observed series with the seasonal component, then I will get the trend out. So this is fine. Okay, so the graph you are seeing here is the black color one is the original, and on top of that, the red one you are seeing is the seasonally adjusted one, meaning it's a clear trend, because we are doing we are removing the seasonal part of it. Okay, so we have another model called pseudo additive model. So this is came up because sometimes few time series doesn't have seasons. If this particular seasonal component is 0, so then I will not get the trend even out during the calculation. So that's why pseudo additive model has came with a different approach. And actually seasonal this pseudo additive model thinks that seasonal and residual components are both dependent on the trend. Okay, when the trend is moving, so on top of that, like these two are depending, seasonal sales also moving well, going high, and residual components also moving along with the trend, but independent of each other. I mean, seasonality is not depending on the residual components are not depending on the seasonality. So we need to look, these two are independently happening. So it is the assumption in case of pseudo additive model. But however, like in our real time series explorations analysis, like we go with with additive or multiplicative. Okay, so we know we have time series, like almost every business has a seasonal component, right? So the need of a pseudo additive model is less. Okay, let's go and go through the code. Okay, so here in this particular page, I am going to explain like how the multiplicative and additive models look like. Okay, here you can see a multiplicative model of time series, where you have the observed time series is growing exponentially, like exponentially. Okay, and it's a trend. Okay, it's trend. It is showing is observed in the sense like it's a clear graph actually. And the seasonal component, it is not growing, even though trend is growing. So it is the seasonal component is not moving. It is very much static. And the residual component, and it is also moving, but it is in the it is moving very negligibly. We can ignore that value. Okay, so to display this, actually I have taken a clear exponentials like 1 square any 1, 4, 3 square any 9, 4 square are 16. So what happens, I got the exponential graph. Okay, since there is a variation in 2, 4, okay, 2, 4, 9, 16. So that graph is moving exponentially, but since for each value there is a change, there is a lap. So that particular thing it is showing here in the seasonality, because the graph will not come like this, right? Like, so the model will be like 2, 4, and then you have 9, then 16. So all those points, all those dots are connected. This is the trend what I am displaying, but the variations are in the seasonal and residual stuff. I think you got my point. The output of this particular function comes like 1, 2, 4, then 9, 16. It's the square I am doing. So data points are like here and there, here and there, here and there, but the trend is growing like up to 100. The trend is growing, but seasonal the curves, the peaks it is showing is related to seasonal and residual. So those are almost constant in this particular model. So we can say the data what we have in the time series is following the multiplicative model. Whereas here what I am doing, I am multiplying I value with some randomly picked value from 0 to from 1 to 9. Okay, so obviously it will have jumps. Okay, it will go up and down like this. It is the observed. So this is the result of this is the plot of your series, of these particular numbers, and then this is the trend we are getting out of it, and the seasonal and residual components are these. Okay, so you can see like trend is not exponential. It is not. It don't have a clear exponential growth. Okay, so that's why we can say like this particular time series is following additive model. Okay, and see basically like when the trend is moving, when in this particular case I have used like square of each number. So when the trend is going, along with season and residual components also move. So that's why we can call this as this series as a multiplicative model, and here it is not. So that's why we can call it as additive model. And so this is about seasonal decomposition. Seasonal decomposition is the algorithm, like how we have HP filter, the similar way we have seasonal decomposition. So what this algorithm does is it will decompose, it will extract the time series components in trend, seasonal and residual components. Okay, so this is the observed time series, and this is the trend component, this is the seasonal component, this is the residual component. It's up to you, like how do you decide. So I feel like this one is a additive model, because it doesn't have much changes in the seasonal component and as well as in the residual component. Residual component, there are some changes, but it's like almost in the negligible interval, like 0.25 to -2, 2.5. Okay, and the data I have taken to show this graph is closing stock market file. Closing stock market, so closing stock price, it doesn't grow exponentially, right? It's a known fact. So you can interpret that this particular data, I mean the season and the residual components are not moving along with the trend, so you can say like it is an additive model. Whereas in the other hand, to display this multiplicative model, I have taken airline passengers data. So airline passengers data is it's exponentially increased, like technology was changing and new aircrafts were coming and people move was started, drastically increased. So you can see a clear exponential trend here, and seasonal trend is also growing because it is showing here 50 and here a lot more, it's a bigger peak. Okay, here bigger peak, and even residual component, you can see here, right, like there are a lot more variation along with the trend. So this is about seasonal decomposition. So let's go on the coding side. I'm going to my Jupyter notebook here. So this is the stats model package. For seasonal decomposition, we have TSA. It's a module, and within that I have a seasonal class. Within that I have a function called seasonal decompose. So I am applying here, and I am specifying here model. Actually, to use the seasonal decompose, you don't need to specify. You don't need to specify what model it is. It's an optional parameter. It's an optional parameter, and the frequency to be used. Frequency it's a mandatory one when you have daily data. When you have monthly data, we don't need to use it, this frequency term. Okay, so let me, here the same thing here with the airline and stock price example. Okay, so when you have daily data and you need to specify here frequency, and if you have monthly, yearly, we don't need to specify the frequency. Okay, model automatically takes up, and here the model is equal to additive and model is equal to multiplicative. You don't need to specify. Basically, like it's an optional component. What happens is this seasonal decompose, this algorithm uses a convolution filter. This is another like a HP filter. How we have in the similar way convolution filter, like to to minimize the time series data and to find out the relationship between them. It's again, it is a mathematical formula. Actually, the option you are specifying here, that is using by the convolution filter. Okay, so it helps to that, I mean, internal of the seasonal decompose. Actually, if you don't specify what model your time series follows, also fine. Okay, so let me draw this. Let me draw this plot. Okay, so you can see, it is very much additive, and you have okay. Let me, if you put here semicolon, like you will not get a double output. Okay, so you can see like residual component scale is very small, and even seasonal component is almost in the same scale. I mean, its value is like between smaller numbers, and you don't see much peaks. Okay, and we can say that this is in this is additive model. and the other one is okay. So the other example we have taken is airline data to see decomposed values. Here you can see like residual component is high, and here it is I mean, no, see, this is actually it is exponential. I mean, it's a multiplicative model. We can see we can say, like, with our eyes, and you have a lot more peaks when it is down, when the season was, I mean, when the trend was down. So here residual component also down. When the trend was up, even the peaks are when you got peaks in the data. And if you want, you can print each component separately. You can assign this output of seasonal decompose to a variable, and you can draw separately each component. Okay, like this. You have other two. You have a for residual. This is the residual component, and see a lot more changes here from -40 to 60, and see this much variation because of the trend. Okay, so that's why we are saying like this model is multiplicative model. This is seasonal stuff. Okay, so what we learned from seasonal decompose, let's summarize. So what we learned here is, okay, let me plot. Okay, this is to understand what is the trend in my data time series, how is the seasonal component, and how is the residual component in my time series. Okay, so this helps us to study, to understand about the data what I have in my time series, and cross verify with what the assumptions I have. Okay, so far what we have learned is, we have learned how to decompose it, and what component time series has, and how can we decompose using HP filter and seasonal decompose algorithms. And yeah, that's it. Like we have learned up to observing the things what we have in our time series. From next sessions we'll start up with the moving average algorithms. Those are like basic forecasting methods for time series. Yeah, okay. The request is, don't forget to subscribe my channel, and see you all. Thank you.